Welcome back. In this video, we give a brief introduction on how to use Tracker software to collect position data from our mass spring chain. In this introduction, we assume that we have already filmed an eigenvalue experiment using our apparatus and that we have an MP4 file ready to be imported into Tracker. Let's begin by opening Tracker. In my case, I look in the Applications directory, scroll down, find Tracker, and open. I'm now in the Welcome window on Tracker software. Next step is to import our Eigenvideo into Tracker. To do so, I go to File, scroll down to Import, find the file that I want, and import it. This import will likely take some time. In this video, I sped up the process so that I don't put you to sleep. On the bottom of our display, we see a playhead as well as a timeline. Under that timeline, we see two arrows. The arrow on the left indicates the first frame of the video that I plan to analyze. The arrow on the right indicates the last frame of the video. I can move these around to set my boundary conditions. Next, I'm going to indicate to Tracker the X and Y axis. To do so, I click on the axis button and I set the origin, the x-axis, and the orientation of the x-axis so that it aligns through the center of masses in my video. I recommend you take some time to make sure that x-axis goes through the center of masses. You can test to see if it's oriented well by watching a few periods of the mass's motion. Because Tracker uses image processing algorithms to create position data by analyzing individual pixels in our video, we need to calibrate the software and indicate a reference length from which all other distances will be calculated. To do so, I'm going to zoom in to find the black marks, which are exactly 10 centimeters apart. Next, let's create a new calibration stick. Here we align the left point on this calibration stick with the left black mark in our video, and the right point with the right black mark. We then tell Tracker that we'd like to interpret the distance between these pixels as 0.1 meters or 10 centimeters. Tracker will track all distances in this video with reference to this calibration stick. Next, we're going to indicate which point we would like to track in our video. To do so, I create a new point mass, click on the mass name, and scroll down to Auto Tracker. I then indicate the center of mass, the exact point in this image that I'm going to track. From this point, I manipulate Tracker's search region to get the best data from this video. You can learn a lot more about how Tracker works and best practices when using Auto Tracker from Douglas Brown's tutorial on using Tracker software. Once we set our search region, we can now search, and Tracker will analyze the movement of our specific point frame by frame. In this analysis, Tracker is assigning a time for each frame, an X position, and a Y position that you see on the screen. Moreover, Tracker can be used to track X velocity, Y velocity, X acceleration, Y acceleration, and many other variables. Once we're done with this process, we can then stop our Auto Tracker and export our data as an Excel spreadsheet. To do so, we go up to File, Export Data File, and then we can save it as a comma-separated variable, or CSV file for short. We can title this file anything we would like, save it to our folder, and open it in Excel, MATLAB, OpenOffice, or any other software that allows us to read this. This file can now be manipulated in any way we'd like. We can change the titles, delete data, or manipulate any of the numeric values. Thank you so much for watching our introduction to how to use Tracker in this experiment. If you're serious about implementing this activity in your classroom, we encourage you to watch all of Douglas Brown's videos on Tracker software. And we'll see you in the next video.